There is a 100-meter tall tower from the top of which a student throws a stone upward with an initial velocity of 40 meters per second. The question is very simple. How long does it take to come back and hit the ground? So the stone goes straight up, reaches a certain maximum height. I will draw the path of the stone in green. It goes straight up, comes to a momentary stop, and comes back down along the same path. But in order to make it clear, I will draw the return path just next to it. This is 100 meters. Now, I need you to understand very simply that while it goes up, it experiences a force of mg downward. We are ignoring air friction. So the acceleration is g downwards, and we are going to take g as roughly 10 meters per second squared. When it reaches the highest point, when it's momentarily at rest, even then it is accelerating because the force of gravity has not stopped. And on its way down, its acceleration is again g downwards. So this entire motion going up and down is one of constant acceleration. Since it is of constant acceleration, we can go ahead and write those three equations. V is equal to u plus 8a, s equal to ut plus half at squared, v squared is equal to u squared plus 2as. We can write those equations for the entire motion directly. For example, if I were to use the equation s equal to ut plus half at squared, s stands for the displacement, not the distance. So when it goes all the way from the top of the tower to the ground, the displacement is in fact this, straight down. Remember, displacement is the change in the position. It started here, it ended here. The fact that it went up and down is irrelevant. Now, like in all physics problems, we have to choose a coordinate system. This is a problem in one-dimensional motion, so I'm just going to take the y-axis pointing straight up. I could take it as pointing down. That's also perfectly all right. I'm just going to choose y-axis as pointing straight up. And just to make things clear, I will take this point, the ground level as y equal to 0, and the top of the tower as y is equal to 100 meters. So what is s? S is the displacement. The displacement s is nothing but the change in the position, in this case change in the y coordinate. The y coordinate goes from 100 to 0, so the change is negative 100. Another way of looking at it is the displacement points in the negative y direction. It's 100 meters long, so it's minus 100 is equal to ut. U is plus 40 times t plus half. A is minus 10. Why is that? I have chosen up as positive and the acceleration due to gravity is downwards, t squared. Well, we have a quadratic equation that's fairly simple to solve. Let me write this down. This is 5t squared minus 40t. Bring 100 to that side, it becomes plus 100, and then I have changed all the signs. So minus 100 is equal to 0. Divide throughout by 5. I have t squared minus 8t minus 20 is equal to 0. And we will now apply our favorite formula, minus b plus or minus square root of b squared minus 4ac plus 80, 4 into 20 divided by 2a. That gives me 8 plus or minus square root of 144, very convenient, that is 12, the whole thing divided by 2. So we have two answers. 8 plus 12 is 20. 20 divided by 2 is 10 seconds. And the other answer is 8 minus 12 is negative 4 divided by 2 minus 2 seconds. So in one step, we got the answer. 10 seconds is the time it takes for it to go up and come down. Why didn't we have to break the problem into different parts? Most students would probably do it like this. Find the time for it to go up, find the time for it to come down. You really don't need to do all that. On the other hand, if you were asked, how high does it go? How long does it take to reach the highest point? How long does it take to come back to the same height? And then how long it takes to hit the ground? In that case, we need to break up the problem into several parts, and let's do that for the fun of it anyway. And if you look at the quadratic equation, we got two answers, 10 seconds and minus 2 seconds. Obviously 10 seconds is the correct answer because it's a positive number, but the mathematics gave us minus 2 also. What do you suppose that means? I will discuss this at the end of this video. Now let's break up the problem into different parts just for the fun of it. So while going up from here to the highest point, what do we know about the highest point? At the highest point, the velocity is 0. So v is equal to u plus 40, because I'm still taking up as positive, u plus a is minus 10 t. Therefore, we get the time taken for it to reach the highest point is 4 seconds. Right away, we can plug that into our displacement for these 4 seconds. S is equal to ut plus half a is minus 10, t squared 16. So that is 160 minus 80. So that gives me 80 meters. So the stone travels to a height of 80 meters above the top of the tower, taking 4 seconds. How long does it take to come back to the same height? Well, you might guess that it takes 4 seconds again to come back to the same height, but all the same, let us prove that. To get to the same height, when it comes back all the way here, starting from when it was thrown to when it comes back to this point, the total displacement is 0. When it starts here, goes up and comes back, 0. So S is equal to ut plus half a t squared. This gives me 0 is equal to, I take t outside, 40 minus 5t. Therefore, the time t has two values, 0 and 8 seconds. Not surprisingly, the mathematics gave us two answers. The first answer is 0 seconds. Why? Because at 0 seconds also the displacement is 0. We just simply asked the question, at what time is the displacement 0? And the mathematics faithfully told us at 0 seconds and 8 seconds later. Now we know it took 4 seconds to go up, so 8 seconds means it takes 4 seconds to come back down, just as we suspected, but this is the proof. Alright, now when it is here, what is the velocity? That is at the end of 8 seconds, v is equal to u plus a t. And the answer is minus 40 meters per second. Again, not surprising, we threw it up with 40 meters per second. When it comes back to the same level, it's moving down at 40 meters per second. How do I know it's moving down? Because the velocity turned out to be negative, and since the positive direction is upward, at this point, the velocity is downward. So now we are going to calculate for the rest of the journey from the top of the tower on its way back, when its velocity is minus 40, all the way down to the bottom. Let's find the time it takes. Now, once again, let me repeat this, something which I've said many times before, which is many students tend to think that v is the final velocity, meaning when the motion ends, and u is the initial velocity when it starts. That's not true. U and v are velocities at any two instants of time of your choice. For example, I am going to take when it's passing the top of the tower on its way back as my initial time, t equal to 0. And I am going to take when it is just about to hit the ground as the final velocity. So we have s is minus 100 again, is equal to ut. This time it is minus 40 t plus half a is again minus 5 because I'm still doing up as positive, half a t squared. Well, let's solve this equation. This is t squared plus 8t minus 20 is equal to 0. So t is minus b plus or minus square root of b squared plus minus 4ac becomes plus 8t divided by 2. So what does this give me? This gives me minus 8 plus or minus 12 by 2. So we have minus 8 plus 12 is 4. 4 by 2 is 2 seconds. Positive answer. And minus 8 minus 12 is minus 20 divided by 2 is minus 10 seconds. So which of these are you going to choose? You will choose 2. Of course, later on we'll worry about why did mathematics give us this other answer. Not right now. So we have 4 seconds to go up, 4 seconds to come back down to the same level, and 2 more seconds, a total of 10 seconds, which we got previously in one single step. So I just want to point out to you that as long as the acceleration doesn't change, you can do the problem in one single step, if you are asked to find the total time. On the other hand, if they ask you how high does it go, then I have to break it up into the first part, upward journey, and then how long does it take to come back to the same level, second part of the journey, how long to finally hit the ground, third part of the journey. I need to break it up only if they ask you those questions. And now, if you have understood up to here, that is good enough. You can stop the video. I am now in the remaining part of this little video. I'm going to talk about why mathematics gave us that negative answer. To do that, I'm going to clear the screen first. Remember when we calculated the time it takes for it to go up and down in one step, we got two answers, 10 seconds and minus 2 seconds. Why did the mathematics give us minus 2? Well, here's the reason. The equation that we used was, for s we put down minus 100, correctly so, is equal to ut plus 40t plus half a t squared minus 5t squared, and we solved for time. But check out this equation. All this equation is asking is, assuming that at time t equal to 0, this stone was traveling upward at 40 meters per second. At what value of time is the displacement minus 100? The mathematics does not contain the information that the student threw the stone at time t equal to 0 and that before the student threw it, the stone was not moving. All that is not contained in the mathematics. The only thing that's contained in the mathematics is at time t equal to 0, the initial velocity is 40. That means at this instant, the stone is moving upward at 40 meters per second. Why is it doing so? Possibly because the student just threw it up with 40 meters per second, or maybe at an earlier time someone threw it from the ground level. With such an initial velocity that at this time it's passing the top of the tower with 40 meters per second. If that is the case, at an earlier time when the stone was thrown up, then too the displacement of the stone was minus 100 meters. So maybe the mathematics is telling us the other answer, minus 2 seconds, as being the earlier time, 2 seconds before the student threw it up. That is, at an earlier time, had someone thrown it from the ground level, maybe it will be moving near the top of the tower as 40 meters per second. Let's see if that works out, right? So let's take this as the initial velocity u now, and the final velocity is plus 40. So for this part of the journey, the displacement is plus 100, s is plus 100, and we know the v is plus 40, and we can ask and a of course is minus 10 because we are still taking up as positive. So what equation can we write with these three? Well, we can certainly write v squared is equal to u squared, which we are trying to find, the initial velocity with which someone should have thrown it up at an earlier time, so that at time t equal to 0, it's passing the top of the tower at 40 meters per second. So u squared plus 2as 100. Well, u squared is equal to 1600 plus this is 20 into 100 gives me 2000. This minus sign becomes plus when it goes to the other side, becomes 2000, and that gives me 3600, from which I gather that u is plus or minus 60 meters per second. Plus or minus. We are now looking at the plus solution because we are asking with what velocity must someone have thrown it up. So if someone had thrown it up with plus 60 meters per second, how long did it take to go up there? Well, that's very easy to find out. V is 40 is equal to u is 60, we just found that out, u plus a t. There you go. T is 2 seconds. That means when this person threw the stone up, it took 2 seconds to reach that point. And it's going at 40 meters per second upwards. So if I take this point at t equal to 0, naturally when else was the displacement minus 100? Answer minus 2 seconds. That is 2 seconds earlier. So this is the beautiful thing. The mathematics gives us all the answers consistent with the equation that you write. You wrote this equation. The rest of the stuff that the student threw the stone at that point and naturally it takes positive time, all that stuff is in your head. As far as the maths is concerned, you simply ask the question, at t equal to 0, the velocity is plus 40. When was the displacement minus 100? And the maths gave you two beautiful answers, 10 seconds later, and it could have been 2 seconds earlier. Thank you.